Hello students, how are you? I hope you all are well. So today I am going to start a very interesting topic, that is law of conservation of energy. So dear students, as you know that I had started your third chapter energy, and in my previous videos I had explained the concept of work, energy and also the concept of interconversion of energy. So today I am going to explain this concept, law of conservation of energy. So this is very important concept. You have to watch this video carefully. So okay, I am going to start this concept. Okay, before reading the definition of the law of conservation of energy, I want to explain this concept with the help of some examples. So I will take the same examples to explain this concept, which examples I had already taken in my previous videos to explain the different concepts. Okay, first of all, take the example of a bike. Suppose we want to take a ride on the bike, or suppose we want to run the engine of the bike. In that case, what we have to do? Of course, first of all, we have to fill the tank with petrol. Why? Because if we want to take the ride on the bike, or we want to make the bike to do the work, in that case we must fill the petrol in the tank. Why? Because of the engine of the bike cannot run by itself. It cannot make the bike to move forward, or in other terms we can say that it cannot make the bike to gain the kinetic energy. Okay, you know that what is the kinetic energy. So generally when the objects are in motion, due to their motion, which energy the object has, call its kinetic energy. So if we want to make the object, means if we want to make the bike to gain kinetic energy, or we want to make the engine to run, in that case we must provide some sort of energy to the engine. So in this way we can say that the bike or the engine of the bike cannot run by itself. It must require some sort of energy. So basically the petrol energy is called the chemical energy. So in this way, first of all, the engine is getting chemical energy from the petrol, and then this chemical energy is used to make the bike to run forward. It means engine required some sort of energy, and then this energy the engine is converting into another form of energy. So in this way, in the case of bike, the chemical energy is converted into kinetic energy. So it means we cannot create energy by ourselves. We can only transform the energy from one form to the another form. In the case of bike, you can easily understand this one. The engine of the bike cannot create energy by itself. It uses some sort of energy. It uses the chemical energy and then convert this energy into the kinetic energies. So you can see the definition here. It states that energy can neither be created nor be destroyed. Okay, first of all, we have to understand this one also. What is the meaning of destroyed here? Okay, I have taken the example of a bike. So okay, in the case of bike, when the engine is using the energy which is in the form of chemical energy, means when the engine is using the energy from the petrol, that time that petrol energy is converted into kinetic energy. Means only in that case the bike can move in the forward direction when the engine is getting energy from the petrol. So okay, it means the engine of the bike is consuming the petrol. Means when the engine starts, then it starts consuming the petrol. So that time that energy is used to make the bike to move in the forward direction. So it means that petrol energy is not destroyed there. It is consumed. So it means when we are spending the energy on the object, then the object gains the energy. So it means the energy is not destroyed. It is transformed from one form to the another form. So that is why it is written here. You can see it states that energy can neither be created nor be destroyed. It can only change its form. So it means we cannot create energy or we cannot destroy energy. We can only change the form of energy. So this is the concept. So like the same way we can take the example of the fan also. So okay, what is the purpose of the fan? It generally circulates the air in the room and also provide comfort during the hot and the sticky weather. So fan is also converting electrical energy into the kinetic energy. So it means if we are not providing electricity to the fan, then the motor of the fan cannot be able to rotate the blades of the fan. So in this way, when the fan is getting the electricity, when the motor of the fan is getting electrical energy, only then it can convert this energy into the another form of energy. Means it can rotates the blades of the fan, and further when the blades are rotating, it means that electrical energy is converted into kinetic energy. So this means the motor of the fan cannot be able to rotate the blades of the fan by itself. So it means it must require some sort of energy, and then this energy the motor is transforming into another form of energy. So in this way we can say that even in this case one form of energy is again converted into another form of energy. And also when the fan is using the electricity, that time fan is consuming the electricity, means it is not destroying the electricity, it is consuming the electricity. And which amount of electrical energy the fan is using, exactly that amount of energy is converting into kinetic energy. So it means in this case the fan is not creating energy and also not destroying energy, it is converting one form of energy into another form of energy. So it means in this case also neither the energy is created nor destroyed. So you can take the example of the electrical bulb also. Okay, what is the purpose of the electrical bulb? Of course it is used to lightening the dark areas, means it generally uses during night time to lightening the dark rooms. So okay, in the case of bulb also, electrical energy is converted into light energy. So you can see also, even the bulb is not converting only the electrical energy into the light energy, it also converting some part of the energy as a heat energy. Okay, so this is also very important concept. When the object is transforming one form of energy into another form of energy, then the object generally transform this energy in two ways. One is useful energy and the other is non-useful energy. But the total sum of this useful energy and the non-useful energy is also is equal to the total energy. So how you can see the example of the bulb again? When we are switching on the bulb, then it starts emitting light. And also if we are standing near the bulb, then we may feel heat also. It means the bulb is transforming this electrical energy in two ways, means light energy and also heat energy. But in this case, the total sum of this light energy and heat energy is exactly equal to the total electrical energy which the bulb is consuming. So in this case again, the bulb is consuming the electrical energy, means it is converting the electrical energy, transforming the electrical energy into light and heat energy also. So in this way, again the bulb cannot create or produce light by itself, or it cannot produce heat by itself. So it means it must require some sort of energy to create or transform into another form of energy. So now you can see the definition. Law of conservation of energy is, it states that energy can neither be created nor be destroyed. It can only change its form. So in the other words, total energy is consumed during transformation of energy, means total energy is always conserved during the transformation of the energy. So I hope this is clear to you. So okay, this example of bulb is also given in your book. So one numerical related with this example is also given to you. So okay, as I had explained to you, the basic purpose of the bulb is to get the light energy from the bulb, and the bulb is getting electrical energy, and this energy is converted into light energy. But in the case of bulb, I had already explained you, generally when the objects are converting one form of energy into another form of energy, then generally the objects convert the energy into two forms, means one is a useful energy and another is a non-useful energy. But the total sum of useful energy and non-useful energy is also equal to the total energy consumed by the object. So you can see here in this example also, the example is about this one, that we have to prove the concept of law of conservation of energy, means we have to prove this law here also. So okay, now see what is the definition. The sample numerical is given. If 10 joule of electrical energy is used to light an electric bulb, means the electrical bulb is using 10 joule of energy to produce light. And if 1 joule of energy is lost as heat energy and the rest is available as light energy, then show that law of conservation of energy. Okay, now the numerical is, we are giving or providing 10 joule of total electrical energy to the bulb, and the bulb is converting this energy into two forms. One is the light energy and another is the heat energy, and it is using 1 joule of electrical energy to convert it into heat energy and the rest of the energy to convert that energy into light energy. Okay, now see the solution. We know that the law of conservation is total energy is equal to useful energy plus lost energy, means generally the total energy is always converted into two forms, useful energy and the lost energy. So okay, now in this case total energy is electrical energy, because of in this case total energy which we are giving to the bulb is electrical energy. So in this case electrical energy is equal to light energy, because of useful energy, of course in this case useful energy is light energy, because the basic purpose of the bulb is to emit light. So useful energy is light energy plus lost energy is heat energy. So okay, now you can see we are giving 10 joule of electrical energy, means in the left hand side we will write down 10 joule, is equal to, so 1 joule of energy is using by the electrical bulb to convert it into heat energy. So in this case 1 joule energy is used to convert into heat energy, and the rest of the energy means of course 10 joule of energy we are giving to the bulb, and 1 joule is used to convert it into heat energy. Then how many energy is left? It obvious it will be 9 joule. So in this way we can say that 9 joule of energy is used by the electrical bulb to emit light. So in this way light energy is 9 joule and heat energy is 1 joule. So you can see left hand side is 10 joule and right hand side is 9 plus 9 is 10 joule. So it means the both sides are equal. So it means it is satisfying the law of conservation of energy. Means we cannot create energy or we cannot destroy energy. Only the object can convert one form of energy into another form. So I hope it is clear to you. So okay, all these concepts or examples which I had explained to you, and the concept of law of conservation of energy and its definition, all are given on your page number 53. And also on this same page number 53, the example of this pendulum is also given to you. Even with the help of the example of this pendulum, the same concept, the law of conservation of energy, is also explained here again. So okay, I will also explain this one. So you can see this is a pendulum. You can see its mean position is this. Means the basic position of the pendulum is this when the pendulum is at rest. Okay, now suppose we are doing the work on the pendulum and we are taking this pendulum from this position to this position. Means we are taking this pendulum from O to A. So in this case you can see its position is changed now. So it means now this bob, this pendulum has a potential energy. Suppose it has a 10 joule of potential energy. Means when we are taking and we are stretching like this, and when we are holding this bob here, it means it has a 10 joule of energy. Now you can see because of its position get changed, because of we do the work also on the bob, and this work done is stored in the bob as a form of potential energy. Suppose this is a 10 joule of potential energy, and when we release this bob from position A, then it starts moving in this direction, and when it starts in a motion or it starts moving, it means that 10 joule of potential energy now converted into form of kinetic energy. But in this case this 10 joule of energy again converted into kinetic energy, that is also equal to 10 joule. Means this ball will start moving in this direction and then it reaches to here, the point B, and again when it reaches to this point, then this again kinetic energy stored as a form of potential energy. Why? Because of now when it reaches to this point, then here it comes to rest. Means only up to this much height it can move, and when it reaches to its maximum height here B, again this 10 joule of kinetic energy stored as a form of potential energy. Again this here on this point B, this bob has a 10 joule of potential energy, and again then it starts swinging in this direction. So like this way the potential energy is converted into kinetic energy, and again the kinetic energy is converted into potential energy. So you can see potential energy converted into kinetic energy, then again potential energy, then converted into kinetic energy. So like this way the potential and the kinetic energies are interconvertible. So this is also the concept of law of conservation of energy. Why? Because of 10 joule of potential energy is converted into 10 joule of kinetic energy. Again this 10 joule of kinetic energy is converted into 10 joule of potential energy. So in this way, even in this case, we cannot create energy or we cannot destroy the energy. Only the one form of energy is converted into another form of energy. So in this case, the potential energy is converted into kinetic energy. So all these examples and the concept is on your page number 53. So you have to read all these points and then you can easily understand the concept of law of conservation of energy. Okay, now I am going to start its examples. So see these examples carefully. These examples are very important. So okay students, on your page number 54, some real world examples are given to you, and these examples are the examples of law of conservation of energy. So with the help of these examples, you can also understand the concept, the law of conservation of energy, and then you will also learn the application of the law of conservation of energy in our real life. So okay, what is the first example? This example is about the working of the roller coaster. So okay, you might have visited the amusement park and of course you had enjoyed the roller coaster ride. And if you had not enjoyed, then you definitely had seen different videos of this roller coaster and also the working of this roller coaster in movies and also in different videos. You have seen this one. So there are so many types of roller coasters are there, but all the roller coasters are working on the principle of this law of conservation of energy. How you can see now? Okay, now you can see what is the working of the roller coaster. So it oftenly moves up and down around this track like this. So many types of roller coasters are there, but all the roller coasters are moving ups and downs around this set track. So okay, now we will learn that how the law of conservation of energy is applicable here. So you can see, first of all, some work is done to bring this slide car from this zero ground to this height. Means this is the total height h. Suppose this is the height, this height is h, and some work is done to take this slide car at this point A. Means that work done is stored as a form of potential energy. Why? Because of when the position of the car, this slide car, is changed, of course then it means we are doing the work on the car, and that work is stored as a form of potential energy. So it means now when the car is at height A, that time some work is done on this car to bring this car from this point to this point. It means now the position of this car is changed. So due to its changed position, this car has a potential energy. So it means at this point A, this car has a potential energy. But when this car is released from this height, that time this slide car moves in the downward direction. It starts moving in the downward direction. That time the potential energy which is at a point A of this slide car, then it converted into kinetic energy. So at point it has a potential energy, but when this car is released, that time this car has a kinetic energy, and of course it starts moving in the downward direction and its speed increases due to this height, and its kinetic energy means increases. But the total kinetic energy remains always same, that is always equal to the potential energy which the car has at this point A, and that time this potential energy is converted into kinetic energy. Now you can see car is moving in this direction, in the downward direction, and it will not stop here. It will reaches to this point B, and due to its motion it starts moving in then upward direction like this. So it means when the car is released from this point A, that time it has a potential energy, and due to this potential energy it starts moving in the downward direction, and when it reaches to the point B, that time it not stops here because of it has a kinetic energy. And with this kinetic energy it starts again moving from B to C in the upward direction. So throughout this point A to B and then B to C, it has a kinetic energy. That kinetic energy is equal to the potential energy which the slide car has at a point A. So here now you can see, so when it is released from A to B, then it reaches to point B, then it reaches to point C. Again when it reaches to the point C here, then this total kinetic energy is converted again as a potential energy when it reaches to the point C. Again when it is released from this point, then again this potential energy is converted into kinetic energy, and again the car slides from the point C to D, and due to its kinetic motion it starts moving in upward direction, and then it reaches to the point E again. So like in this way, this roller coaster is working on the principle of law of conservation of energy. So in this case, the potential energy of the slide car, when the car is at a height, that time its potential energy is converted into kinetic energy when it starts moving from the height. And then the motion of the car is like in this way because of it is released from the height, and then it reaches to the another height again, and then this kinetic energy is converted again as a potential energy, and then again when the car is released from that point, then that potential energy is converted again into kinetic energy. But throughout the whole journey the kinetic energy and the potential energy remains same. So this is the law of conservation of energy. Means we cannot create energy by ourselves and we cannot destroy energy by ourselves. The whole working of this slide car is also explained through this flow chart. Okay, now you can see when high position I had written here, you can see high position. High position is a point A. Means when the slide car is at a high position, that time it is at a point A, that time it has a potential energy. When the car is released from this height, that time it reaches to the low position, that is B, that time it has a kinetic energy. Why? Because of that time the car is moving. So it means when it reaches to the low position, again due to its motion it starts moving in the upward direction. At that time it is also in the motion, so that time it has again the kinetic energy. So at a point B it has a low position, but because of its kinetic energy it starts moving from the point B to C. Again from the B to C, when it is moving, then again it has a kinetic energy. And now when it reaches to a point C, that time it has again a high position. And then this kinetic energy is converted again as a potential energy. And when the car is released again from the point C, then it reaches to the from the point C to D. So again when it is moving, then this potential energy is converted again as a kinetic energy. And when it reaches to the low position D, it will not stop here because of it has again the kinetic energy, and due to its kinetic energy then it starts moving in the upward direction. So again this has a kinetic energy at the low position also, so it continues moving. So it means it is convert, then this again has a kinetic energy in this case also, because of it still moving from the point D to E. And when it reaches to a point E, that time it has again a high position, means that time this kinetic energy is converted into again potential energy. So in this way this roller coaster is working. So I hope this is clear to you. This is the concept of the working of the roller coaster, and it is based on the law of conservation of energy. In this case the potential energy and the kinetic energies are interconvertible. So I hope this is clear to you. So now the next example is about the working of the hydropower plant. So okay, we know that what is a hydropower plant. In hydropower plant electricity is produced. So okay, now I will explain you that how this principle, law of conservation of energy, is again working here, and how this power plant is based on this principle. So okay, first of all see the diagram of this power plant, this hydropower plant. It is exactly same diagram which is given in your book. So you can see this is a reservoir, and in this reservoir water is stored at some certain height. You can see this much is the height of the water. So you can see the water is stored at some certain height, and also here is a pipe through which the water is released to fall. So it means you can see here is a pipe and water is flowing from this pipe and reaches here. So you can see here is a turbine. I had also marked out by the arrows. You can see this is a turbine, and this turbine is connected with the generator in the powerhouse. You can see in the powerhouse this is a generator, and this generator is connected with this turbine, and through this pipe the water is flowing and then it reaches to the river. Okay, now you can see in the powerhouse also. So you can see the generator is connected with the wire, and these wires further connected with the transformer, and through this transformer electricity is further distributed by the power line. So this is the setup of the hydro power plant. So okay, I will explain you that how this hydropower plant works on the principle of the law of conservation of energy. So now you can see when the water is stored at this height, and because of this height this water has a potential energy. So it means up to this height this water has a potential energy, and when this water is released from here, you can see when we are removing this intake from here, then the water is released from here, and then water starts flowing from this pipe because of this height. So I hope this is clear to you. Then this potential energy is converted into kinetic energy, and the water starts flowing through this pipe, and when it reaches here, then further this kinetic energy of the water again rotates the wheels of the turbine. You can see here is a wheel, and when the water is flowing, when it strikes to the wheels of the turbine, and that time it rotates the wheels of the turbine, and further these wheels rotates this generator, means further this turbine runs this generator, and when the generator is running, that time electricity is produced, and when this water is flowing, then it reaches to here, then it reaches to the river in this way. So it means when the water is stored at this height, that time it has a potential energy, then this potential energy is converted into kinetic energy when the water starts flowing from this pipe, and then this, with the help of this kinetic energy, this water rotates the wheels of the turbine, and this turbine further runs the generator, and then this generator produces electricity, and then this electricity with the help of these transformers distributed further through the power lines. So in this way we can say that potential energy is converted into kinetic energy, and then this kinetic energy is converted into electrical energy. So on this principle this hydropower plant is working. Okay, with the help of this flow chart it is also explained here. You can see in your book. Okay, when the water is in the reservoir, due to the height in the reservoir it has a potential energy, and when this water is released through the pipe, that time due to its potential energy it is released, and then this potential energy is converted into kinetic energy, and through the pipe water starts flowing. So it is flowing, so it means then it has a kinetic energy. And when the water reaches to the turbine from the pipe, you can see here, through the pipe water reaches to the turbine, then it further rotates the wheels of the turbine. Again in this case, the potential energy is again converted into kinetic energy, and when the turbine further rotates the generator, that time again, because of now the wheels of the turbine is rotating, that time it has a kinetic energy, and further is running the generator, it means again it has a kinetic energy that is then converted by the generator as a electrical energy. Then this generator converted this kinetic energy into electrical energy. So in this way the potential energy is converted into kinetic energy, and then kinetic energy is converted into electrical energy. So in this way hydropower plant is working. It is based on the law of conservation of energy. So I hope this is clear to you. So dear students, I had completed your third chapter, energy. So I hope it is clear to you. I had explained the whole concepts through the videos, and you can see all these videos to understand the concept. Now you can read the chapter, and after that I will complete your book work also and your question answers also. So while reading, still if you have any confusion, then you can call me also. You have my contact number, and you can also subscribe my channel to see the videos directly in YouTube. So till then, learn the physics and stay healthy. Thank you.